You know that moment when you hold a glass of white wine up to the light and it's just perfect? That crystal clear, brilliant sparkle? It's gorgeous. But here's the thing, that clarity doesn't just happen. It's not magic. It's actually some seriously cool science. So let's dive in and uncover that incredible journey from a murky, cloudy liquid to the magnificent wine that ends up in your glass. Right after fermentation, wine is, well, kind of messy. It's cloudy, it's unstable, and it's just not ready for prime time. That pristine, totally stable clarity that we all expect when we buy a bottle, that's the result of a very deliberate, multi-step scientific process. It's all designed to clean up and, importantly, future-proof the wine. That is the million-dollar question, isn't it? What's actually in there that's making it so hazy? It's not just one thing. It's a whole microscopic soup of different particles that winemakers have to deal with. So let's break down who the culprits are. Okay, so our story really begins right after the yeast has finished its job of making alcohol. The wine is officially here, but it's jam-packed with all these suspended solids that make it look cloudy. It's completely unprepared for bottling, and this is the fundamental problem every single white winemaker has to solve. So, this haze comes from two main groups of troublemakers. On the one hand, you've got particles you could actually see with a microscope, things like leftover yeast, tiny bits of grape, things like that. But the real challenge, that comes from the invisible colloids. These things are microscopic molecules that are so tiny and light, they just float around forever. And what's worse, they actually prevent other particles from clumping up and settling out on their own. They're the real tricky part of the puzzle. So how in the world do you get rid of a microscopic mess like that? Well, the first big phase is called clarification. You can think of this as the great cleanup, the initial large-scale operation that's designed to remove the vast majority of all that stuff floating around in the wine. And the key technique here is something called fining. It's really cool. The winemaker adds a special substance, a fining agent, that literally acts like a molecular magnet. It goes into the wine, attracts all those tiny suspended particles, and forces them to clump together into bigger, heavier lumps. And once they're heavy enough, they sink right to the bottom, leaving the wine above them way, way clearer. And winemakers have a whole toolkit of these fining agents to choose from. There are organic ones, like gelatin, which is a protein, and mineral-based ones, like bentonite clay. The choice is super important because different agents have different electrical charges, so they attract different types of particles. It's all about using the right tool for the specific job to pull exactly the impurities you want out of that particular wine. And you know, this process can get surprisingly complex. For example, white wines are naturally low in tannins. Those are the compounds that give red wine that kind of dry feeling on your tongue. Well, some fining agents need tannins to work properly. So a winemaker might add a tiny bit of tannin, then add gelatin, which binds to it, and then add bentonite to clean up any excess tannin that's left over. It's this precise three-step chemical dance to get the wine perfectly clear without messing it up. Let's look at one of these agents up close. Casein, which is a milk protein, is a total powerhouse. It doesn't just clarify. It has this really strong bleaching effect, which is perfect for fixing a wine that's maybe gotten a little oxidized or has a slight color stain. Plus, it pulls out iron, which can cause the wine to get cloudy later on. It's a real problem solver. Now let's compare that to something called PVVP. This is a synthetic agent, and its superpower is preventing white wines from browning over time. So think about it like this. Casein is fantastic for correcting color problems that already exist, but PVVP is the master of preventing future color problems, all while being super gentle on the wine's delicate aromas. It's a specialist. Okay, so the wine is clear, mission accomplished, right? Well, not quite. The next big question is, will it stay clear? That brings us to stabilization. This whole stage is about future-proofing the wine and making sure no new cloudiness pops up after it's in the bottle, sitting on a store shelf, or in your wine rack. There are two main long-term threats here. First, leftover proteins can decide to clump together if the wine gets too warm. And poof, you've got a haze. This is fixed with adsorbents like bentonite. The second threat comes from cold. Tartaric acid can form these little crystals that people call wine diamonds. They're totally harmless, but they look like bits of glass, and nobody wants that in their wine. The solution is genius. You just chill the wine way, way down before you bottle it, forcing all those crystals to form and drop out early. And here's a really fascinating one, a problem called pinking. Certain white wines can develop this strange pinkish gray tint if they're exposed to oxygen. To prevent this, winemakers have a whole playbook of strategies. using PVP, making sure sulfur dioxide levels are just right, and most importantly, protecting that wine from any and all contact with oxygen. So we have clarified and we have stabilized. But to get that final, ultimate, brilliant shine, there's one last step: filtration. This is the final polish, a physical process of screening the wine to remove any last microscopic particles. And it actually happens in a few stages. The whole process starts with a fairly coarse filtration, often using something called diatomaceous earth. This is what's called the roughing stage. You can think of it as the first heavy-duty pass, designed to catch all the bigger stuff and just get the wine ready for the more delicate steps that are coming up next. Next up is the polishing filter. At this point, the wine gets pushed through these special pads that have much smaller pores. We're talking between 1 and 10 microns, which is tiny. This step is what removes even finer particles, and it's where the wine really starts to get that bright, polished look. And finally, the grand finale, membrane filtration. The pores in his filter are unbelievably small, less than a single micron. I mean, this pass is so fine that it removes any and all remaining yeast or bacteria. It effectively sterilizes the wine, guaranteeing it's perfectly stable for the bottle. Absolutely nothing gets through this final checkpoint. And so, after all of that chemistry and physics, all the fining, the stabilizing, and the multi-step filtering, we finally arrive back where we started, with a perfectly clear, stunningly brilliant wine that's ready for you to enjoy. You know, this quote from our source material really nails the why behind all this effort. Because white wines don't have the deep color or heavy tannins of a red wine to hide minor imperfections. That absolute perfect clarity is completely non-negotiable. It's one of the first and most fundamental signs of quality that you, the consumer, see. So, the next time you pour yourself a glass of crisp, clear Chardonnay or Sauvignon Blanc, I hope you'll take an extra second to look at it. Because you're not just looking at a drink, you're looking at the beautiful, delicious end result of a truly meticulous scientific process. So is it art or is it science? I think you'll agree it's a perfect blend of both.